Hi, I'm Keith, and I'm into Android dedicated device fleets. Today's session, we're going to talk about x86 versus ARM as the underlying silicon that you should consider to use in your hardware for dedicated device fleets. Now, for context, I've been around this space for quite a long time. When I was at Microsoft, I did the initial deals with ARM and Intel for the ARM architecture and x86 specifically for Windows CE. So I've been around this for a few cups of coffee. Now that said, you have preconceived notions about x86 being inappropriate for dedicated device designs. And in the Android world, there's been no viable enterprise-level Android OS that you could use. Esper is taking care of this with the Esper Foundation for Android on x86. So with that, we should be ready to dive in and check it out. The way I'm going to do this today is I'm going to cover off on the hardware aspects, the OS aspects, and then app considerations, and then finally dive into a top level of use cases of how you should look at it. And with that, it should give you good context to make a great decision for your business. So let's go explore. Hi, I'm Keith Stott, VP of Innovation and Solutions at Esper, and you're watching Fleet Geek. Build your dedicated device fleet your way. So let's do a pragmatic dedicated device focus dive into ARM versus x86. So when you say ARM, x86, what first comes to mind? Well, for me, using kind of ancient examples of the lineage of ARM versus x86, when I think of ARM, I think of smaller, good power consumption, no heat sink, great thermals. And when I think of x86, I think of big, power hungry, a lot of heat. While some of that is still true today, we should do the step back to say, in today's world, how do you compare ARM versus x86 for dedicated? All right, first let's start out with the basics. What is ARM and what is x86? Well, they're both microprocessor architectures built for essentially different use cases. The lineage of ARM was, interestingly enough, primarily around anti-lock braking systems. This is where they got their first initial design wins decades ago. It is a RISC architecture, reduced instruction set, and so it is designed to run efficiently on hardware. While x86 is a CISC instruction set, so it's complex, and really the lineage for x86 is the PC and the server world. And so with that, they've both taken their paths where today you see ARM as the dominant design for smartphones and tablets, which means, by the way, the Android world. And with x86, it's synonymous with PCs, laptops, and is Windows and Linux primarily. So this kind of frames it from a dedicated device perspective. Typically, you think of most of the designs that you build around Android solutions, Android fleets, are really around ARM, but x86 should be explored and considered because it may be good for particular use cases. So let's start with some of the design characteristics comparing the two. Like we talked about, ARM tends to be lower power consumption, smaller form factors. So this way you can do tablets, you can do smartphones with it, and has a plethora of design options. This is driven by the fact that ARM is a licensable architecture. So what the ARM consortium, if you will, does is take the core IP and the licensees are able to spin it into different silicon designs. So that's why you have a lot of choices from MediaTek, Qualcomm, and even Rockchip, which is very popular in the dedicated device space. This goes to ODMs that can then build around it particular designs that meet the customer needs. It could be built for consumer mass market use cases. And the majority of this is around Android. And so for Android dedicated device fleets, you have a lot of choices. Now going over to the x86 side, since the main market driver, frankly, in the dedicated space was Windows, along with Linux to some extent, you don't see the same level of customization that's being built there. It's a more standardized model where it really is the PC architecture, and historically has been primarily focused around the designs for servers and PCs more than anything else. The other big issue here is the availability of Android itself as an operating system for x86. While on the ARM side, because Google is driving GMS in the smartphone space, there is a lot of IP and a lot of options in terms of the ISV market that's available for you to create your dedicated device solution. In the absence of an enterprise-grade Android, it's been very tough for the market to coalesce around designs built on x86. Now, this issue has been addressed by Esper. This is where I introduce our foundation for Android. So what we do is we take AOSP and we build on top of it features that are applicable to dedicated device use cases. So there's a separate series on this, a lot of information you can get from us. But suffice to say that one thing that we do is we do build for various ARM targets, but the key is we also provide an enterprise grade for Android, arguably the first time in the industry that you're going to see Android built in a form and offered in a way that makes it appropriate for dedicated device use. Now this starts to get us into the devil of the details from an operating system perspective. When you're dealing with ARM, you're typically beholden to whatever party built the operating system image for what you get, as well as how that operating system is supported over time. This is a story of security patches that are delivered for an OS release and how they have to flow through whoever the device maker is using some kind of over-the-air delivery mechanism to get you those updates to keep you secure in the ARM world. This can be rather hard because the ARM world is driven by GMS with the smartphone and the tablet market, which is consumer-oriented, right? You have quick turn times. Usually these devices only last 3 to 4 years at most in the market. And once they go obsolete, the OEM, the ODM, is not going to provide any security patch coverage, any updates for those devices. Now, interestingly enough, when we jump over to the x86 world, because Android is based on the Linux kernel, and on the x86 side, the Linux kernel is actively and well maintained, this gives us the opportunity to offer long-term support over on x86 because on the Esper side, we can control the whole operating system stack. So this lets us take advantage of what Google does to provide security patches to AOSP and apply it over in the x86 world so that unlike ARM where it's hard to do, in the x86 world we can offer long-term security patches or long-term security support packages. And in fact, right now we will go contractually obligated to 10 years in this space. There is a bit of devil in the details. You have to be willing to jump Android versions if you do this so we can stay under the shadow of security patch coverage provided for AOSP. But that's a huge, huge differentiator that if your CISO is really sketched out and concerned about exposing security vulnerabilities through your dedicated device fleet, you can have a better time here using Foundation in order to cover it compared to ARM. So that all sounds fine and good, but what about applications? And so part of it is ISVs, part of it is just developing your own in-house enterprise applications. So let's look at the ISV side. The reality is that when you look at Android, it's driven by targeting ARM and dominated by Play Store. And Play Store is part of GMS. It's not part of the AOSP world. And so what do you do when you have these massive devices from ISVs that arguably do not target x86-based devices? And by the way, generally speaking, because this is an AOSP world, you're not going to get Play Store over here. The reality is when you build an app, it's relatively simple for you to be able to target x86. There's this thing called an application binary interface. This is going into Android Studio, application developer stuff. But essentially the default when you build an Android app, it includes the support to be able to run on x86 in it. If it doesn't, that means it was a choice by the ISV not to include it. Now, they may have good reason to do so, because if an ISV is targeting the mainstream ARM market on modern Android OS versions, there really isn't a need to include an x86 ABI in it. And they probably want to lower the scope of their test coverage and just focus on the mainstream market. However, that said, if it's an enterprise type of ISV, it's relatively trivial for them, if they have a business opportunity, to create the ABI and include it in their APK, their application, the ability to run on x86. Now, the subtopic here is about GMS. And if you do include dependencies to GMS, it's not going to run on AOSP, but that is a general problem between GMS and AOSP anyway, meaning if you were doing an ARM-based AOSP device, you would still need to have the application written so that it would run on AOSP and not have GMS dependencies. So that's independent of whether ARM or x86. From a practical example, we have worked with several ISVs where they build their enterprise application for Android on ARM, and we have a customer that is using our foundation for x86, and the customer needs that ISV to be able to deliver the app on x86. In fact, we've had several that had GMS dependencies as well. We actually worked through it with them. First of all is figure out what you need, what you can get on AOSP that's provided by GMS, and then just simply build that x86 ABI and be able to deliver it. So it was a relatively simple operation. It worked out well for both the customer and the ISV. They got new market coverage. So don't let the fact that if you have an x86-based system and you get that APK and it doesn't run, that doesn't mean it's over. And that's something we're really good at working through with ISVs, with customers. So if you have that issue, please come to us. We can talk about it. So this goes to enterprise app developers. So if you have your own in-house developers, it's a similar type of thing, but it's completely within your control. You still have to deal with, do you have GMS dependencies or not? And are you building that proper ABI to be able to output from an enterprise perspective? You can do that quite easily here. So an important side note to cover, which may not be obvious, is when you look at infrastructure, we talked about apps, right? But let's look at the overall solution, that Esper is a cloud-based infrastructure for doing DevOps for dedicated device fleets, right? And you could argue that, hey, the world is all about ARM, and this infrastructure just works with ARM, and it needs GMS, and all that. The reality is our infrastructure was built to both be ARM versus x86 agnostic. Right? This is ignoring the foundation OS, which you absolutely need to be able to run on the device to be able to do this, as well as be agnostic to GMS versus AOSP. So what this means for us is you can easily run your solution across a mixed fleet of ARM or x86-based Android devices. We don't care. We've taken care of it. And so with one pane of glass, you can completely manage your fleet across multiple Android versions and be able to run whether it's x86 or ARM. So we basically take care of all that for you. Yes, but what about the money? And what I mean by that is when you build these devices, of course, there's a cost associated with them. And historically, because ARM is very much driven by the very high volume consumer market, you tend to be able to find better price points for devices, right? And so this is involving what's called the BOM, the bill of material cost. These are the cost of the components that go into the devices. And because the smartphone market is very competitive, you see a lot of very cost-effective solutions that you can deliver. It's not perfect because there's a trade-off there. That BOM is optimized around these consumer scenarios. It may not be always right for you, and remember, you're going to have to deal with the security patch situation and being able to keep your device up to date. If you don't necessarily care about that, and you're really focused on getting to rock bottom cost, this could be a better world for you. And in fact, you may want, if you have sufficient volume, to commission a device via an ODM. We actually see a lot of Android 7.1 devices out there, Android 7.1. You're not getting any security patch coverage on that, and there are vulnerabilities that are as wide as a barn door running on that particular version. So be it. Over on the x86 side, this is a bias against x86. Oh, it's more expensive. Well, yes and no. It really depends on the solution that you're trying to build, because there are cost-competitive x86 designs that can get you the right economics around your solution, but it really depends on your use case. So this is where you have to crunch the numbers. What is the longevity of the device? Are you looking to have this in the field for 10 years to get your payback? Right? That's one aspect of it, where it may be better because if you go with Foundation, we can cover you for 10 years. You're not going to easily get that, if at all, over in the ARM world. Now, a sub-aspect of this then goes to design. What can you do with building your device? And this is where some of the detail comes into play, like thermals. It's true to say that x86 tends to run harder than ARM. And so there's a line that you cross where you're not going to be able to use x86 for certain designs, including power consumption. That's another parameter, right? However, you have to know where that line is, meaning that if you get into a situation where you can run against your solution appropriate performance and keep your thermals such that you can heat sink it or you could forced air cool it if you needed to and you're okay with that, then x86 may be better. And if you're plugged into the wall, to what degree do you care about power consumption? There's the eco-green side of it that certainly should be considered. But if you're doing the pure play of what kind of design do you need to get the max out of your use case, x86 may be very, very interesting for that. Talk about thermals a little bit more. You're in situations where perhaps you need a sealed unit. Think about a kitchen with grease or dust, and if you have venting with a fan, it's not very good over time because it can actually cause shorts on the board as the coating over time accumulates on the board. Interestingly enough, you can get x86 designs that are completely sealed and kind of get you out of that mode and put you in a good place. Now, the other thing about x86 versus ARM is that typically with ARM, you have to commission a design or you have to take something that's already there to be able to build it. So it's kind of up to you to shape it or take what you got. x86, more of a modular design. Think of system builders, right, where you have a box that you have all the different components with the PC bus that you can put them on. That lineage lives today in a way that you can get things called NUCs. And these NUCs come in different shapes, sizes, extremely configurable. So that way you can work with a manufacturer to get exactly what you need. So I just wanted to show you NUCs as a concept. So you look at these. It's interesting where they're basically PC compute boxes that are self-contained. So if you're in a situation where you literally need to just drop in and compute, and you take care of the screen, the user interface elements associated with the device, keyboard, mouse, potentially touch screen, and it doesn't need to be integrated like you typically get in the ARM world, this can be a very, very good option for you, give you a lot of flexibility in terms of how you approach your business. This is a Lenovo Nano. This is a Simply NUC, very cost-effective devices, great warranties, can run our Foundation OS, get your long-term support all right here. Think about kitchen display systems. And this is an interesting area that we're diving into and exploring because when you look at what happens in KDS today with an ARM-based device, there's a one-to-one correspondence between the compute and the screen. What we're finding is that with x86, because it has better graphics performance, better horsepower, if you will, you can actually drive multiple screens off of one compute and potentially give you superior economics to what you could get with ARM. So these are the areas that we're exploring at Esper because we think x86 can actually give you a better compute per screen cost compared to ARM. Jumping back in to dispel further notions about form factor. Oh, x86 is huge and big. Look at this device from Xenio. This is a POS system. It looks like it could be running ARM, but this is running x86. Elkhart Lake, as a matter of fact, one of the more modern IoT architectures that come from Intel. So just because it's x86 doesn't mean it's big, chunky, lunky. This is a very svelte, thin machine that runs very well with our Foundation OS. I do want to circle back to my earlier comment about the semiconductor manufacturer ecosystem associated with this, right? And so I mentioned before, On the ARM side, you have Qualcomm, you have MediaTek, I mentioned Rockchip. There are a whole bunch of manufacturers over here, a lot of choices. Boy, in the x86 world, what are your choices? It's primarily Intel and AMD. Wow, that looks like a very short list, right? Not a lot there. Well, fact of the matter is, if you take Intel on their own, they have such a broad line of processors that they're constantly driving and revving that it's almost akin to your choices that you get over in the ARM world. It's not an exact analogy, but I'm saying don't take the perception that it's this limited world over in the x86 side for the availability of the CPU designs that you can build into your systems. And again, there's that flexibility, because think of it like these chips are hard dropped in to a particular board that you have to commission typically. You're fixed, you're tied to a supplier. Over on the x86 side, especially with Foundation, you have a lot of flexibility. As long as you have that Intel chip in it, you can select from different makers of NUCs. You could even take those NUC designs and spin them into your own boards quite efficiently. In fact, you can do this onshore if you wish in the United States and be able to get the exact type of design that fits your use case that arguably would be harder to do over in the ARM world. So again, it all comes back to what are you trying to do? What is your use case? What user experience are you trying to create? And we're quite happy to work with you on this to figure it out. We love this stuff. I'm a CPU nut to an extent. I come from the Windows CE world. I've done Linux on ARM, and have spent a lot of time in the x86 world over here. So at Esper, we're happy to help, talk to you about our Foundation OS, what we can do for you to get you the right device fleet for your dedicated use case. Thank you.